Here's four review questions, Math 95 questions. First one, how can the graph of this be obtained from the graph of that? Okay, the graph of this looks like this, something like that. It's a quadratic function with origin or with the vertex right on the origin. This one, and when we look at the general for transformations, if we look at that general thing, it looks something like this, where I want to know what is in each of those spots. This one has a minus out front in the A spot, and the A spot has to do with vertical stuff, vertical stretching. If the sign is negative, then it flips it over. So that minus sign, the impact of that is it's going to flip over, or the graph will be reflected on the x-axis. Okay, so that's what that does. And then the 7, that's in the C spot, and that's the thing that moves things to the left or to the right. Since the sign is negative, it's going to move it to the right. Okay, so that 7 is going to give me a right 7 movement. And then the 6 is in the D spot, and that's the up-down movement. And so this one is going to move the graph up by 6 units. Now, they didn't ask in the question to graph that, but you could graph it. So if you have to go right 7, so 1, 2, 3, 4, 5, 6, 7, and then up 6, 1, 2, 3, 4, 5, 6. So that's where your vertex is going to be. And then it has to flip over. So the graph will look something like that. I'm not exactly sure where the x-intercepts are, but in this question, I'm just generally looking for what transformations have happened. Okay, in this question, they give us a polynomial and they want us to factor it and then solve the equation. Well, to factor any polynomial, I guess if you have a quadratic one like this, if you have a quadratic, you can just say, hey, put things in brackets, find two numbers that add to 5 and multiply to 6. But in this question, if it's a quartic graph, you can't start with that. You do want to end up with this, and since it's a quartic, you want to end up in the end with 4 of these, but there's different ways of going about getting all of those factors. And the key thing for us here is to use synthetic division. So I'll put synthetic division down here, all my coefficients, making sure I account for each degree. So 4, 3, 2, 1, and 0, they're all there. And then I just start guessing. So I've got 24 as my last number. I just start picking numbers that multiply or divide into 24 evenly. And hopefully I come up with a 0 at the end. I'll try 1 to start with. 1 times 1 is 1, add, minus 9. So this would be a minus 9, add, that'd be 26, I think. Multiply, add, multiply. Ooh, I guess the right one right off the bat. Now at this point here, what I'll have from this 1, that's an x-intercept, so the factor would be an x minus 1. And then this piece below is x cubed minus 9x squared plus 26x minus 24. That's what that thing gives me. Because I have a remainder of 0, I can write that. Now, if it's a cubic, I still don't have ways of factoring like I did up here with a quadratic. So I need to do synthetic division again. So let's try 2. So I'll bring this down. And if you don't get one that works, you just keep trying numbers. I'm picking ones I hope that'll work, but if you don't pick the right one, just keep trying numbers. So bring down, multiply, add, multiply, add, multiply, and add. Again, another remainder of 0. Excellent. So what that means then is I first had an x minus 1. Now I've got an x minus 2 because of this. And then on behind that, I'll have an x squared minus 7x plus 12. Now this is a quadratic, so I could keep going if I wanted to with synthetic division. Or if it's a quadratic, I can just do my normal things with quadratic. What things multiply to 12 and add to 7? It'd be a negative 4 and a negative 3. So my factors that they wanted, that's what they wanted right off the bat. So my polynomial, I could write it like that, or I can write it in factored form. Then they say solve the equation when f of x is equal to 0. So if this is 0, then I need to solve that equation. I need to use the 0 property. Anything multiplied by itself to give 0, one of them's got to be 0. So either x minus 1 is 0, so that gives me x equals 1. And then same thing with all the others. And I'm going to get those as the solutions to this equation. Now, to take a step further, it'd be nice to graph that. I know a quartic graph, positive quartic graph, has sort of the W shape. And if I impose that W shape on those 4 x-intercepts, I'll get a graph that looks sort of like this. You didn't need that for this question, but that's about what it would look like. And the y-intercept right there would be a positive 24. Okay, here's another question. They say, given this polynomial, do basically the same thing. Factor it if you can, find the zeros, linear factors. Got it. So it's an x cubed, so in the end, I need to have that out of it. It's a cube, so I can't say what multiplies to 20 and adds to something else. I can't do that. So synthetic division is my first guy I'm going to try. Let's start again with 1. 1, that'd be 1 minus 5. Minus 5, 8. Yeah, it's not going to work. 1 minus 6, 13 minus 20. Let's try 2. 2 be negative 4. That'd be negative 8. That'd be 5. That'd be 10. No, that didn't work either. How about 4? I'm just trying to think of what number it could be. 1. So it'd be 4 minus 2 be minus 8. That'd be 5. Hey, there we are. There we go. Okay, so this gives me x minus 4 is a linear factor, and then I have a quadratic factor of this. Now in this case here, it's a quadratic, so I could try doing more synthetic division, but I don't think it'll work well. But here I could try and factor, but I don't know any two numbers that multiply to 5 and add to a negative 2. So really the factoring, I need to get brackets eventually, but I can't just straight factor it. So in this question, I'll need to use the quadratic formula. So the minus b plus or minus all over 2a, and then I'd plug in 1 for a, negative 2 for b, and a 5 for c, and solve that out. Once you come up with your number here, then they say they want it to be in factors, linear factors. So once you have your number at the end, then you would put it into factors. So you'd have x minus, and then whatever you got from here, you'd plug into there. And you'd also have x minus the other number that was in there, because you'll have a plus minus, so there'll be 2 of them. The other one you put into here. All right, last question. They say find the horizontal vertical asymptotes for this function. And to find the horizontal asymptotes, there's 3 rules. Here they are over here. And it all has to do with what degree the numerator and the denominator are. So if the degrees, if the top one is greater than the bottom one, there's no horizontal asymptote. If they're samesies, then it's whatever the coefficients of those highest degree terms are. And if the top one is less than the bottom one, then y is equal to 0 is your horizontal asymptote. So you need to know those 3 rules. So over here, it looks like they're samesies. So it's like this one. So I just have to figure out what the coefficients of the highest degrees are. So it'd be 2 over 1. That'd be your horizontal asymptote. In other words, at the horizontal line of 2, y equals 2, the graph could not cross through that line. So it could come up and get close to it, but it couldn't cross it. Okay, for the vertical asymptotes, they don't have a rule, but the way to figure them out is to figure out what numbers for x would give you 0 on the bottom, because that's not allowed. So what I'm looking for is I want x squared minus 3 is equal to 0, so that's just the denominator, and I want to solve this equation. And for those values of x that make this true, those will be x values through which the graph can't cross. In other words, they're asymptotes. So to solve this, I'll move 3 over to the other side, take the square root of both sides, and I get a plus or a minus root 3, which is 1 point something or other. So on this graph above there, I would have a line like here. Oh, this is crossing. It couldn't do that. So I'd have a vertical line right there at positive root 3, and another vertical line right here at a negative root 3. And the graph could do whatever it wants in between those dotted lines, but it cannot cross them. Okay? So I don't know what the graph will look like. It might look something like that, but the main point is it won't cross those dotted lines. Hopefully that helps you with those questions.